Welcome to the e-learning classes. Today for the 10th class students in the chapter Coordinate Geometry, we are going to study about centroid of a triangle. Children, we have already known about what is a centroid in our earlier classes. So here, centroid is the line joining the vertex and the midpoint of the opposite side. So here in the picture you can see ABC is a triangle. A, B, C are the three vertices of the triangle. And you can see the points P, Q, R. Those are the midpoints of AB, BC and CA. So the line joining the vertex and the opposite midpoint of the side is called as the median. Now here AQ is a median, CP is a median and BR is a median. You can clearly observe that all the three medians are concurrent lines. That is, they are passing through a same point, G. So this point of concurrence is called as centroid of the triangle. It is generally denoted with G. Now, there is one relation between the distances. So here you can see that AG is to GQ is 2:1. That is, AG is 2 times of GQ. Similarly, BG is to GR is 2:1. BG is twice the distance between GR. Similarly, CG is to GP is equal to 2:1. So, the centroid divides each median in the ratio 2:1 from the vertex. Median. The line joining the vertex and the midpoint of the side opposite to the vertex is called as median. There are three medians for a triangle. Three medians are concurrent lines. The point of concurrence is called as centroid. Now here is a small video. You can see a triangle ABC and G is the centroid. D, F, E are the midpoints of the three sides AB, BC and CA. Here we are going to change the position of C. That is, we are going to see different triangles. And I want you to observe that the distance AG is always double that of GF. Similarly, BG is double that of GE. CG is double that of GD. As the position of C changes, we are going to find different types of triangles. You see that always G lies inside the triangle. We also observe that all the three medians are concurrent lines. You can observe that the distance from the vertex is always double the distance from the centroid to the midpoint. The centroid divides the median in the ratio 2:1 from the vertex. If A is x1, y1 and B is x2, y2 and C is x3, y3 are three vertices of a triangle, you can observe it in the figure. So there is a blue triangle, all the three vertices are mentioned, and D is the midpoint of BC. So the coordinates of D are x2 plus x3 by 2 and y2 plus y3 by 2. So AD is the median and G is the point which divides AD in the ratio 2:1. Now let us apply the section formula for these. So M1 M2 is equal to 2 comma 1 and x2 is x2 plus x3 by 2 and y2 is y2 plus y3 by 2 and x1 is equal to x1 and y1 is equal to y1. Substituting all these values in the section formula. So we get 2 into x2 plus x3 by 2 plus 1 into x1 by 2 plus 1. That is the x coordinate. And similarly the y coordinate is 2 into y2 plus y3 by 2 plus 1 into y1 by 2 into 2 plus 1. Simplifying, we get the coordinates of centroid as x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So when we know all the three coordinates of a triangle, we can find out the coordinates of the centroid. Now let us see an example. Find the centroid of a triangle with vertices -1, 3, 6, -3 and -3, 6. So here x1, y1, x2, y2 and x3, y3 are given. We are going to substitute in the formula for the centroid. So centroid is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So substituting these values, we get -1 plus 6 minus 3 by 3, 3 minus 3 plus 6 by 3. So we get 2 by 3 and 6 by 3, which is nothing but 2 by 3, 2. So the centroid of a triangle is the point 2 by 3, 2. These are the coordinates. Now let us go for the second example. Find the third vertex of a triangle whose centroid is 1, -4 by 3 and two vertices of the triangle are 3, -5 and -5, -1. So here two vertices are given and the centroid is given. You are asked to find the third vertex. So third vertex is not given. So let us assume the third vertex as x, y. So x1, y1, x2, y2 and x3, y3 are 3, -5 as x1, y1, -5, -1 for x2, y2 and x, y for x3, y3. So the centroid is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So substituting these values, we get 3 minus 5 plus x by 3 minus 5 minus 1 plus y by 3. That is nothing but 1, minus 4 by 3, which is the centroid given in the problem. So -2 plus x by 3, minus 6 plus y by 3 is equal to 1, minus 4 by 3. So equating the x coordinates, -2 plus x by 3 is equal to 1. So -2 plus x is equal to 3. So with this we get x is equal to 3 plus 2, that is 5. Similarly, equating the y coordinates, -6 plus y by 3 is equal to -4 by 3. So both the denominators are equal. So -6 plus y is equal to -4. So y is equal to -4 plus 6, that is equal to 2. So x is equal to 3 plus 2, that is equal to 5. So the third vertex of a triangle is 5, 2. So children, today we have studied what is a centroid, how does the centroid divide the median, what are the coordinates of the centroid when three vertices are given. Thank you children for watching the video.